So, good morning, students. As I said in the last session, right, in Epsilon NFA, the main purpose of Epsilon NFA is to construct DFA for the regular expression. So, for that, regular expression should be converted to NFA with epsilon transitions, right? So, the name of the algorithm is Thomson construction algorithm. So, today we will see Thomson construction algorithm. Okay, right. So, the algorithm is the input consists of a regular expression R over the alphabet sigma, right, or C. The output is an NFAN accepting the language L of R, right. So let us see the method. Now let us begin. Now begin by parsing R, that is a given regular expression, into its constituent sub-expressions. The rules for constructing an NFA consist of basis rules for handling sub-expressions with no operators and inductive rules for constructing large NFAs from the NFAs for the immediate sub-expression of a given expression. So I repeat, students, first you should know what is regular expression. What are the various what is it symbols used there? Okay, what are the various operators? How to identify the sub expressions? Right. So once if you know that, we can easily construct the NFA. Now, the basis. Now the basis for our RE to epsilon NFA is for an expression epsilon construct the NFA, right? So I should start with the state I. For the input transition epsilon, I will reach the final state F. So this is the algorithm designed by Thomson. You are supposed to memorize this algorithm. Based on this algorithm only, we will be able to construct the epsilon NFA. This is first step. Here, I is a new state, the start state of this NFA, and F is another new state, that is the accepting state for the NFA. Right? So, this is the basis for all the regular expression. Now, let us see the second one. For any sub-expression A in C, construct the NFA. Right? So, the base is this. So, you have one starting state, you have one accepting state, and there is a transition. Right? You have the starting state I for the given input symbol A, right? The transition leads to F, which is the final state, right? So we are our Thomson is following the mathematical induction concept. Okay, now next, so we have seen the basis step. Let us go for the inductive step. Suppose n of s and n of t, right, are the NFS for the regular expressions s and t respectively, right? And so we assume that there are two regular expression s and t, and the operator between them is r. That means I can either go to s or I can either go to t, right? So I start with the initial state, that is I, right? Using the epsilon closure, I can either go to n of s or n of t. Now I should reach the final state, no? So at the end, I have the epsilon transition from n of s as well n of t, and I reach the final state. Then for the regular expression s of st, that is s is followed by t, and the operator is a dot operator, right? So in that case, I'll start with I'll be having n of s, then it will be continued by n of t, and I'll reach the final state, right? So the first one in your inductive step is your or operator, and the next one is the dot operator. So or means either you will go to n of s or n of t. Dot operator means n of t is followed by, right? So you have n of s, and n of s is followed by n of t in dot operator. Now, then is your clean closure. So, I already said plus means positive closure. It means it is repeated one or more number of times, and star is clean closure. It is zero or more number of times. Right. So, I am going to repeat n of s n number of times. Right. So, for null transition, what I should do is from the initial state to the final state, I will be having one epsilon transition. Okay, so the next one in the inductive step is suppose R is equal to S, then L of R is equal to L of S, and then we can use the NFA N of S as N of R, right? So let us see the protocols here. N of R has at most twice as many states as there are operators and operands in R. This bound follows from the fact that each step of the algorithm creates at most two new states. So if you see an example, you will understand this. N of R has one start state and one accepting state. The accepting state has no outgoing transitions, and the start state has no incoming transitions. Each state of N of R other than the accepting state has either one outgoing transition on a symbol in C or two outgoing transitions both in E. Right, now let us see an example. Construct an NFA for the given regular expression A or B star A. Right, so your sigma is having two input symbols A and B, and there are two operators, or operator, then clean closure, and then you have one dot operator. Right, so that is if you consider A or B star alone, it is two operators. If you consider A or B star A, it is dot A. That is, A or B star is followed by A, right? So it is dot operator. So we should begin step by step, one by one. First, let us assume A alone. So I start from one state to another state. I write A. Actually, you are not supposed to number the states. Numbering of the states should be done at the last. Now, okay, let us not number the states as 2 and 3. Okay. Now, next is for B, I'll assume. So there will be a start state, there will be a final state, and the transition is B. Now, what is A or B? It is your S or T, and it is combined by epsilon at the beginning and the end. So you should memorize that, and you should follow the protocol, and you should do A, then B at the bottom, and both are combined by epsilon. Now you are supposed to number the states: 1, 2, 3, 4, 5, 6. Okay. Now let us see. NFA for R of Y is equal to R3 is the same as that of R3. Now we have what? R3 clean closure. Now what is our clean closure? You are supposed to write N of S, and there should be one self loop, epsilon. And you will have an addition state at the beginning and at the end, and you will be having one epsilon transition for null transition. Okay. Now you copy this R3 as such. Right. From the state 6 to 1, you should have one self loop. And for null transition, clean closure means what? 0 or more number of times. For that, you add one state at the beginning and you add one state at the end. So this will be your starting state and this will be your final state, and you will be having a null transition. Right? So it includes 0 or more number of times. And finally, this A or B star is followed by dot A. So you write the copy the same states. So then you have a transition for A. Now you can number the states. So numbering of the state should not be done like this. So you will be having only the start state, final state. Numbering should be done finally, and the numbering should begin with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is very important concept, because your regular language, right, will be having regular expression. We are converting the regular expression to epsilon NFA. Then we will be converting this epsilon NFA to DFA. Right, and already we have discussed about minimization of DFA. So after that, we'll be having minimized DFA. So this is the algorithm for converting the given regular expression to epsilon NFA using Thomson construction method. Okay, students. Okay, thank you, students.